Please pause the video and take a moment to read this important safety message.
All right, hopefully another fun video here today at Blue Glow Electronics, a much anticipated day. As you guys know, about a year or so ago, I invested in the etracer, and it has been an amazing vacuum tube tester. Not only does it do typical tests like a TV7 or whatnot, it also does curve tracing of your tubes. And the owner of the company, Chris Chang, he is super helpful, super friendly, and continues to develop the product. It seems like every month or so he's coming out with a new revision of the software with either new features or tweaking something. But at Expona earlier this year in Chicago, he announced something he was going to be making called the Sbox12, which is an expansion unit for this. So if there's ever been a downside to the etracer, it has been that these wires here, kind of on this first panel, you have to manually connect to this board, which is the tube socket board, and you have to change those with each tube type. Now, if you were testing like a 12AU7, the pin out on it is the same as if you were testing a 12AX7, so you can kind of swap between some similar families. But when it comes to swapping between a 12AU7 and a 6L6, you have to pull all these wires out. In the software, it will tell you when you load the 6v6 configuration how to go through. It'll say like put HV1 into pin number 3 or whatnot, and you have to redo that. So a little bit clunky, a little bit cumbersome, a little bit time consuming, but this new expansion box basically automates that process. It will, you'll see here in the picture I'm showing you, it will feed from the top box down here into a box that mounts below this that has the relays in it, and it basically does all the pin mapping connections for you. So when you load a tube type, instantly you're ready to go and start testing that. So Chris put these up for sale last week for existing customers. He had a $100 discount going on them, so I jumped in very quickly and sent him my PayPal, and 3 days later, guess what showed up at my door? This box. So today's video is focused on assembling this, getting it connected up to this, and using it. So stay tuned, should be fun. Okay, we've got all the parts and components laid out now. As you can see, we got the relay board over here, our USB jumper, the front plate, we've got the banana jumpers. Looks like each of these are ferrite beads that'll end up snapping onto these. You got a couple jacks here that you're going to just female banana jacks, and it's got the same little connectors. Looks like Chris again provided a tool to be able to tighten those with. Looks like there's 4 rubber feet for the unit. You've got some little connectors here. It looks like you'll be making something, and some wire here, so I assume you're going to be assembling some connectors. I put all the screws here in this little connection, in this little metallic bin. You've got your corner pieces that hold the 2 units together, your side pieces, your top and your bottom plate, and it looks like that's all there is to it. Let's jump over to the manual now. Okay, one thing I've always liked about Chris's website, it seemed to be fairly well organized, and here you would find the official etracer documentation and software, and that is under the downloads section. If you kind of follow through this, somewhere in here I'm sure there will be a manual for the Sbox12. Let's go to download that. There it is. Let's download it, and look, we've got the manual for the Sbox12. Okay, I'm going to give you a quick walkthrough of the manual, and then we'll go over to the box, and you can certainly read this for yourself if you buy one. But it basically shows you how this is going to end up looking when it's mounted, and basically you're going to end up feeding high voltage 1 to ground negative heater 1 and heater 2 up to similar up top here, and then these bottom pins here are going to connect into where the tube socket, the pins are on the tube socket board. You can kind of see here, it shows you these here are going to feed down, and then these right here, and I'm assuming these right here won't be used as part of this anymore. And then shows you you're going to have to make a little connector here, It's this Molex connector, and there's actually two of them. There's one here with these and one here with just two wires. Kind of shows you where they're going to plug in at on this board here on J14 and J1304. This is where the power will feed in. This is the USB connection. These are the destination pins outward. It does tell you that there are 12 connections here, and there's less than that on the other board, and that's for some future implementations. You can kind of see here what you'll end up doing. You'll end up mounting in these jacks here and feeding them down to that Molex connector. It does talk about the fact that this is a, where does it tell it? It tells the story here somewhere. Yeah, it is a 7 by 12 relay matrix, so a total of 84 relays total. And it says here that the it can, certainly the reason for a 7 by 12 instead of a 6 by 12 is the additional possibility to connect the negative V pin from the etracer to different output pins with or without a resistor in series. Today I think he has a 1 mega ohm resistor in series there. So it kind of gives some future flexibility. And I like that. Chris is thinking forward. Shows you how to put the little box together. Then you mount the board into the box. And we're going to do this. We'll make this connection here. Then we'll mount the screws and kind of install the box. Show you how to connect the back here. And then we will get into how to wire these between each other. It'll show. And then finally how to wire the blue ones, and where you'll mount all these. Imagine we'll end up using some kind of glue to hold, hot glue or something to hold these in place. And then he gets into how to load the software here and how to tell it to detect your Sbox12. And then it also, as you can see, as you pull up a tube type here and it makes these connections, it'll empower the relays and make all the connections for you. And then Chris also has a piece of software here that he's created that lets you test all the relays. He does mention at some point in one of his notes that these are a lot of mechanical relays, and over time you could have one that fails potentially. He tells you what kind of relays they are if you need to replace one of them, but this utility would help you test and validate whether you have any issues or not with that. And that's really all there is to it. Let's jump over and build this thing. Okay, we're going to start with the bottom, which has the vent plate and the plug-ins back here. And you just take these two little connectors here, or two end pieces, and you'll put them one on each end, and you'll just basically put your screws in here, and you've got holes on the front here and on the back here for that. Okay, I've got the sides on using the beveled screws. Up next, Chris lists these as M4 screws here, and there's 4 of them, and they will hold the rubber feet on the bottom. They will go into these holes from the bottom here. And then next we're going to mount the the actual relay board here using 6 of these little M6 screws right here. They're the ones that have the washers built onto them, and they'll go in these standoffs, these 6 standoffs right here. Alright, so you can see we've got the 4 screws on the bottom mounted in here. And then the relay board just basically drops down in here and mounts onto the little risers, standoffs. And as you can see, there are 1, 2, 3, 4, 5, 6 that we will end up putting these little screws that have the washers into them. I typically mount screws into boards like this using a hand screwdriver instead of this. You just don't want to torque too much onto the PC board. Alright, we've got it mounted in at this point. Up next we're going to just drop the front plate on here like this and put the 4 screws to hold it in place, and those again will be the beveled screws. Up next we're going to mount these banana jacks in just like we did on the original etracer, and they go in the same color order they went in the original etracer. So you kind of got your 2 reds here, you've got your black for the ground, you will end up having your yellow for the negative voltage, and if I get that screwed off, you'll end up with that, and then you'll end up with your 2 heater connections here. And we will, just like the first time around, you will end up putting these, what I call kind of moon washers, on the back of each of these. and then you will put your little lock nut here, lock washer on it. And then, like I said, Chris provided a tool here that is specifically made for kind of tightening these in. To be honest, this might have been easier to mount these before I put this board onto the front, but nonetheless, we'll get them on there. Guess what? I decided it was much better to pull this unit off the front. That way you can kind of run these down with your hand, and then just at the very last minute use that little tool to put them on, because when you have it mounted down there, you really can't do this with your hands. As well as I'm sure if I read the manual in detail, Chris probably told me to do this first, but guys like me in manuals, sometimes we like the trial and error method a little better. But my trial here and error has hopefully helped you do it right the first time. All right, one thing I learned in assembling the original units is get these things good and tight. Don't worry about whether these little blades here all line up. You can use a pair of needle nose pliers and adjust them when you're done to get them all in a row or however you want them for soldering. Okay, and if you'll remember from the first time, we're going to use little snippers here to snip these little units off of these tabs. It's a really simple little thing to do. Okay, if you can see here, I've stripped back off this wire, I'd say somewhere around 3 millimeters or 1/8 of an inch, and that's just enough for your wire to kind of drop down into this little slot here on the Molex connector. And what you've got here is you've got 2 big tabs on the back that you're going to want to pinch around the actual wire insulation back here, and then you've got the little pieces up front here that you're going to want to clip around the actual wire itself. And this is a little bit tedious. I recommend a pair of needle nose pliers, but if you can get this done, you know, it's just kind of bend one tab over at a time, then kind of grab the next tab, push them, squeeze them together like that. And then what we're going to do is just bring these over, and I'm going to use just a little alligator holder here, just some really fine solder. This is 0.32 diameter, and what we're going to do is just solder this front part together a little bit so that there's no chance of the actual wire down in there and this connector, one, ever coming apart, or two, not having good connectivity for each other. Then, as you can see, I've got the connector here, and you'll have this little lip on the edge of it on one side over here, and then the other side's got the little rounded piece. The side with the little rounded piece opposite from that, you'll see that's where the little square notch goes down in. And you'll just drop that down in and kind of push it until it snaps good and snug, and you'll hear it snap, and you'll have it on there. And then what I'm going to do is just kind of zoom back out here. Whoops, zooming the wrong way. What I'm doing then is I'm just sort of putting this back over, just sitting it on top there, and then I'm getting a feel for how long that wire needs to be to kind of flow over here and solder. And I'm just kind of cutting it off, giving it a little, maybe a ½ inch, ¼ inch of extra room right now. But we've got our 2 wires, and we'll keep going down the line. Okay, as you can see now, I've got all the wires in here. What I'm doing is I'm just kind of bringing them over. I've stripped off probably about 4 millimeters here. And what I'm doing is just kind of routing these into the holes and then routing them over here. And what I'm doing then is just kind of bending over the other side of the wires here as they come through the hole, so that it's somewhat flush with the body of the blade there. And then I'm using a little bit larger soldering iron this time, or tip, and I'm soldering these to the blade themselves as they come through, just like that. And then I'm coming back over here, and I'll be able to just keep these at the end. I'll probably put a zip tie here, right here in this spot, and we'll keep all these together nice and neat. Alright, as you can see, all 6 of them wired in now, soldered up well. On to the next stage. Okay, at this point you can go ahead then, this is all the soldering and connecting. All these are just mounted to the surface board, don't need any connectors. Next up, you can then mount the top plate on here with 4 screws to hold it down, and you do not need to mount the front plate. I'll show you why here in just a second. Okay, once you get the box, the top on top of the Sbox12, the reason you don't want to go ahead and put these front screws on is because you're going to have to remove the ones here on the front of your etracer as well, because these little mounting brackets that Chris provides are actually going to go like this, and they will actually hold the 2 units together using the same screw holes as before. And Chris recommends putting the 2 inner ones in first and then the outer ones. And as you can see here, got these mounted together, starting to come together as a single unit now. We're going to flip it over on the back, remove all the screws there again, and go about mounting the same little brackets in place. All right, we got it all mounted together. The front and the back all kind of glued together. It's nice little tight unit. I'm going to try to make these connections between the top and bottom as tidy as I can, and we'll get this unit hooked up and tested. All right, we've got all the wires running. I did make one assumption that was wrong. When you clip these on, they're tight and stay in place. They don't roll around. And I used just a little bit of Velcro there to hold all this together, made for a nice, neat little package. I'm happy how this has turned out. Okay, I've just launched the etracer software, and for those new to the software, when you launch it, it's a single large executable, and it takes about, on my PC, about 30 seconds to actually open up, but once it does, you're good to go. And I'm going to connect to the actual etracer, and let's see what happens here. There we go. We are connected. And now we're going to go up to Options, Configurations, and we're going to say Enable the Sbox12, and it goes out and reads and finds it at that point, and we can click Apply, and then we can exit out of this. Now when we say File, Load to Configuration, let's load something like the 6L6 right here in triode mode. I just heard relays clicking like crazy over here, and now the connector, the tester, has been configured for a 6L6. One thing to mention real quick, the assembly of the actual box over there on the bench, if I take out the making the video part of it, probably about 45 minutes to an hour to take your time and do it right. So it's not real bad at all. Okay, up next I'm running the Sbox12 GUI utility, and basically you can test the connectivity to your Sbox and then our Sbox12, and then if you turn on this output enable, as you click through each and every one of these settings, you'll hear a relay clicking in there, and I'm going to go through and check them all, and you can also use a multimeter if you wanted to ensure good connectivity, but at least I know all the relays are engaging on each of these as we go through. And finally, I thought I would, load a tube configuration like a 12AX7 here, and then I would turn around and load a tube configuration like a 6L6. And I thought we could drop a 6L6 tube into it real quick, and I'll pause the video while the heater warms up, and we'll test it. Okay, now we're just going to run a quick test similar to what you would get out of a TV7 or 539C or whatnot test. It'll just test a point in the operating point on the tube, plus or minus 5%. And as you can see here, this tube, reference is 4,700 micromos. It tested out at 4371, so a little less. And 40 milliamps is the reference plate current, and this one tested with 3371. But I'm really just trying to show you can switch between tube types now quite easily, and I'm enjoying it. So hats off to Chris for making this. I think this is the best tube tester in the market right now. is the best thing going, because one, you've got a modern platform that integrates with your computer. Two, if you find a tube type that you don't have, you can make your own configuration file for it. And three, Chris continues to update the platform and do new things with it. I can't name another platform out there like that. The Amplitrex, while maybe it's a great platform, doesn't test at the same high voltage as this one does, nor has Chris done, the different Chris at Amplitrex, done any real development on that unit, and probably going on close to 10 years now, whereas this one, we have new stuff coming out almost every month. So I'm excited about it. One last thought I had in my head, I'm sure if Chris maybe would have been started over with all this, maybe he would have made just one unit that had both the Sbox12 integrated into it. But I'm kind of glad it's worked out the way it did, because you're able to buy the etracer for one amount of money, and then later, if down the road you had the money to add the Sbox12 and do an upgrade. So it kind of gives you two cost paths to get into this unit, and I'm happy the way it's turned out at the end of the day. So thanks for watching, everybody, and stay tuned for more videos.